Well, I guess we'll get going now.
Everybody mute, please.
Okay. Except for me, I guess. Okay, so I'm just going to share my screen here to start. All right, well, welcome to What's Up Over Edmonton for September. My name is Jeff Robertson, a member of the RASC here in Edmonton. I always start off with a picture of the Queen Elizabeth Planetarium, and if any of you people have joined before, you'll note I've got a new picture. I went out last week when it was nice and sunny out and took a couple extra pictures. So anyway, the idea for this session was originally that we would have this live at the QEP with people in chairs and maybe even a cup of coffee after, where we would talk about what you could see in the sky that month, and then after, if conditions warranted, we could go outside and have a look, set up some telescopes. Of course, COVID has put paid on that. The QEP has not yet reopened after an extensive renovation. It will be run by the TELUS World of Science when it does reopen. I say this is What's Up Over Edmonton because our skies over Edmonton are quite a bit different than what is shown in a lot of the popular astronomy magazines and what's talked about on the CBC when they have Andrew Fazekas, the night sky guy, or do an astronomy session on the Weather Channel. They tend to focus it on the skies around Toronto. So as an example, this is the sky over Toronto at 11 o'clock at night on July the 5th. And the constellation I always point to is this guy here, which is Scorpio. A constellation, I only see the entire constellation of Scorpio is when I am in Southern Ontario to visit my wife's relatives. In Edmonton on July the 5th at 11 o'clock, Scorpio this is about as high as it gets in Edmonton. You can see the top, the bright star Antares, and then down a little bit of the body, but you never see the entire scorpion in Edmonton or indeed in Alberta. You just can't see it. We're just that much further north. Most of the information I use for this is taken from the Observer's Handbook, which is put out every year by the Royal Astronomical Society of Canada. Every paid up member gets a copy of this in the fall. It is 352 pages of absolutely all the information you would ever want to go out and observe the sky. So what's up? Oh, let's admit that person. There we go. What's up in the sky in September? Shorter days, longer nights. So in the evening sky, Saturn and Jupiter are the dominant objects. Neptune, which is a telescopic object or a pair of good binoculars, reaches opposition on the 14th. That means it will rise as the sun is setting and set as the sun is rising the next morning. Venus is very, very low in the west-southwest throughout the month, 30 minutes after sunset. Very difficult target to see right at this time. And with that, we'll go into a little segment with my astronomy program. I use Starry Night for what's in the sky in September. Now, before I begin, let me point out that today the sun rose at 6:43 in the morning and will set at 8:22, although looking out my basement window, I do not see anything but cloud. So At the end of the month, on September the 30th, the sun will rise at 7:34 in the morning and set at 7:11. We're past the equinox, so the nights are longer than the days. I'll start this portion just briefly. I'm going to keep the time at 8:45. We've got Venus here very, very low in the west-southwest sky, and Mercury popping up also. Mercury actually reaches its greatest eastern elongation, which means it's the farthest distance from the sun in its orbit in this cycle on the 14th. But even if I move it to the 14th, at that same time, 8:45, Venus is just about set, and Mercury isn't even there. So very tough targets. Mercury, I would say, is be impossible to see this go around, and Venus, you have to catch it fairly early. Okay, now setting the time at 9:45 on tonight. We see the Saturn and Jupiter high in the south-southeast sky. Jupiter is unmistakably bright. Saturn is dimmer, but still one of the brightest objects in the sky at this time. This is a photograph I took of Jupiter and Saturn just a few nights ago in my backyard, hence the power lines. So Jupiter is on the left, it's the really bright one, and then almost a straight line across is Saturn. If you have a small telescope, you can point it at Saturn, and you will. Even in a 60 millimeter refractor department store telescope at 40 power or 50 power, you will be able to see the rings of Saturn. Maybe a little bit later on in the night than 9:45, but certainly once it gets dark, the rings will show up quite clearly. Same goes for Jupiter. If you have a small telescope, you will be able to see these two equatorial bands for sure. If you have a larger telescope, you can tease out more detail, and you can watch the four big Galilean moons on the first, Europa on one side, then Io, Ganymede, and Callisto. And if you watch it at the same time every night, you will see that they actually move around. And there's even some shadow transits in there too. And joining Jupiter and Saturn is Neptune, which reaches opposition on the 14th, which means it will be rising as the sun is setting. And if you have a medium telescope, you can definitely make out a bluey, greenish, more bluey than greeny disk of Neptune, and you might even spot its big moon Triton. Now the green line shown is the ecliptic, which is the path that the planets, the sun and the moon, follow through the sky. And in September, the ecliptic runs very low above the horizon at sunset. If we follow the paths of the planets through the month, starting at the first, every day at the same time they move further, there we go, to the west. And here comes the moon, and you'll see on the 16th we have a triangle with Jupiter, Saturn, and the moon, like a nice isosceles triangle. The moon is about 4 degrees below Saturn and Jupiter. Makes a nice picture if you want to do that, although if the moon would be very overexposed if you try and get proper exposure on Jupiter or Saturn. And then the following day, the moon moves below Jupiter, and again you have kind of a tilted isosceles triangle there. And then you'll also notice that the sky is getting darker at the same time as we move through the month. Here we are at the 22nd, which is the autumnal equinox, where the length of day and night are equal, and the sun shines equally on both hemispheres of the planet. Also, I should point out, I'll just back up a couple days to the 20th, and the moon is full on the 20th, and on the 19th, if you have a telescope, you can use the moon as a marker and go slightly up and to the left to find Neptune. As we continue going through the month, we get to the end, September 30th, the last day of the month. Now I've left the date at the middle of the month, September the 15th, and as we look straight up, we see Cygnus the Swan, the tail star Deneb, Lyra, whatever, the Harp, with its very bright bluey white star Vega, and down here Aquila the Eagle with its bright star Altair. And these three stars, as I've mentioned many times, make up the summer triangle. And there we have it, Deneb, Vega. Some people say Vega, I say Vega. A friend of mine had a Chevy Vega in the 70s. Well, it was a terrible car. The engines failed on them. And Altair. If you're familiar with the classic science fiction movie Forbidden Planet, Altair 6 was the planet the spacecraft was headed to, and it was circling this star here. Okay, if we swing around to the north, we see the Big Dipper is riding fairly low in the northwest from my backyard. I can't really see it because I have this big tree in the middle of our yard, so I have to go out on the driveway behind my garage, and then my neighbor's got this security light that shines all night. And anyway, right now Ursa Major, or the Big Dipper, is kind of a tough target just because of trees and lights and such, but once winter comes and all the leaves fall off the tree, be easier to spot. And as you follow the arc of the handle to Arcturus, which was riding fairly high during the summer, but it is getting lower and lower in the west as the months go on. Of course, here's our old friend Perseus, where the Perseid meteors seem to radiate from, right up from this spot here last month. I hope you all had a chance to get outside, hopefully to a dark site, and watch the Perseids. My wife and I went up to Bonnyville, actually, and enjoyed the show from up there. Moving on, presuming you're in a dark site, there is Pegasus and the Great Square of Pegasus, which is very easily seen in a dark site. And excuse me, if you follow the legs of the horse through these two stars here, you will come to, again in a dark site, of course, the great galaxy in Andromeda M31, which is the closest spiral galaxy to our own. And near Pegasus and Perseus is the crooked W of Cassiopeia, the queen in her throne. I believe I did do a little talk about that constellation several months ago. I may revisit it. We'll see. I know what I'm going to be doing next month, but that's a surprise. Turning to the morning sky, and I've set the time at 5:15 in the morning. So as you can see, the ecliptic runs fairly high up in the sky in the morning, and we see Neptune is heading for the western horizon, and it is also joined by Uranus, which reaches opposition next month, and we'll talk about it then. Jupiter and Saturn have already set. So in the morning sky, we've got our familiar winter constellations. We have Taurus, which also contains, at this time, the very first asteroid discovered series, and also this is the largest of the asteroids in the main asteroid belt between Mars and Jupiter. And along the ecliptic, we have Gemini, Cancer, and Leo starting to show its head in the middle of the month. And below Gemini and Taurus, the most dominant constellation of the winter sky, the Orion the Hunter. And below him, just peeking out at this time of the year in the morning, is Canis Major, the great dog, his Orion's faithful hunting dog companion, which contains the very bright star Sirius, the brightest star seen from Earth. Now, I should mention that for the first part of September, in the early morning, around 5 o'clock, there's several very good passes of the International Space Station. And if you would like to get up and watch them, go to spotthestation.nasa.gov and input your location. If you're in Edmonton, put in Edmonton. If you're somewhere else, put in that location, or if your location isn't listed, the nearest location to you. Now in Edmonton, because we are at 53 degrees north latitude and the station's orbit is inclined at 51.5 degrees, it never comes directly overhead, and it is always in the southern part of the sky. It can, depending on where it is when it comes over, it can be very low in the south, or it can be very high in the south, getting in excess of 60 degrees above the horizon, which is, fairly high, or anywhere in between. So check out that website if you want to view the space station. It can be as bright as Jupiter or even brighter, depending on how the sunlight hits the solar panels when it's coming over. Looking straight up, we see that our old friend Perseus is almost directly overhead in the morning, middle of September. And our summer triangle is heading towards the northwest horizon, and it's going to where it will park itself for most of the winter. And one last thing, you'll note that the morning sky in September mirrors the evening sky in March. In March, the Ursa Major, the Dipper, is heading up toward the zenith, where it will reach its highest point in late April. But in the morning in September, it's heading on its way up. And maybe next month I've got a story. Somebody sent me an email when I was the public education director of Edmonton about Ursa Major, the Big Dipper. He had a question about two of the stars in the Dipper that he was worried about. But I'll share that. I'll save that story for next month. So with that, I think that closes off the constellation portion. And if there are any questions, let me know. Alistair, you got anything to add?
Yeah, actually, just a neat little thing about Jupiter's moons, the ones discovered by Galileo. A little historical fact that having seen those moons and being able to show them to other people, it was sort of raw proof that not everything revolved around the Earth, which is what was thought at the time. So it was the, something's going around a not Earth thing. So it was a big, momentous discovery.
True enough. And yet some people didn't believe them, didn't believe their own eyes. Yes. Okay. All right. All right. We'll move on to the lunar portion here.
What do you see when you look at the moon when it's full and round? Do you see a balloon? Does it look like a cookie with the bite taken out? What do you see when you look at the moon? It follows a path every month.
Okay. Starting with new moon on September the 6th. First quarter is on the 13th. The moon is full on the 20th. And as it is the closest full moon to the autumn equinox, it is known as a harvest moon. But it also has the name corn moon or barley moon. Last year, the harvest moon was actually in October because the full moon came at the very beginning of September. And so the closest full moon to the equinox was actually early in October. So September is the harvest moon. And third quarter is on the 28th of the month. I usually pick something from the a feature on the moon from the Observe the Moon certificate program, either binocular or telescopic certificate program. But this month I took something from a different source, although the objects I'm going to talk about are in both programs. It's something called the lunar triangle, and this is something that was cooked up by John Reed, who's a member of RASC Halifax, and he's written a few books on observing. So what he calls the lunar triangle, and because of the harvest moon, this is something you can easily see when the moon is full. So this is a picture of the full moon, and it comprises three bright craters with significant ray patterns. The first one is Copernicus. The next one is Kepler. And the third one is I had this pronunciation down yesterday when I was practicing, Arcturus, something like that. And these, sorry about that. These three bright craters form a triangle. So because they all have significant ray patterns, that does indicate that they are fairly young, and youngish on the moon is like 100, 200 million years old, as opposed to 3.5 billion years old. They are in the Maria areas with not as much cratering as in the highlands. So here we are again, the three craters again. Now, the three craters, the largest is Copernicus. It's 93 kilometers across. It's 3.8 kilometers deep, and its ray pattern is the most largest of the three, and they extend 800 kilometers, and they intersect with the rays coming off of Kepler and Aristarchus. I think that's how you say it. Copernicus, of course, was named after the 16th century astronomer who proposed the heliocentric, or published the heliocentric vision of the solar system. Kepler is the smallest of the craters. It's 32 kilometers across, 2.6 kilometers deep, and named after the 17th century astronomer who gave us his 3 laws of planetary motion. And then Aristarchus is 40 kilometers across, 2.7 kilometers deep, and he was a 3rd century BC Greek astronomer, and he postulated on the possibility of a heliocentric solar system. And he also put forth the idea that stars were actually suns, but very, very far away. Now, I have this one picture, and this is a picture of Copernicus taken from a fairly shallow angle. And this was taken by Lunar Orbiter 2 in 1967. And at the time of its release, this was called the picture of the century, because no one had seen anything quite like that. Let's flip my notes here.
Shine on, harvest moon, up in the sky. I ain't had no lovin' since April, January, June, or July. Snow time, ain't no time to stay outdoors and spoon.
That was louder than I thought. As I mentioned before, the September full moon this year is called the harvest moon. It's given that name for a few, well, because it's a very bright moon. It shines all night long, and it gives light to allow farmers to get their crops off. And it also has a characteristic that it rises on consecutive days, very close. The rising time isn't very far on consecutive days from what you normally expect for a moonrise. And I just show this, and it is because of the narrow angle of the ecliptic to the horizon, which causes this effect. So here is the moon at September 19th at 8:30. On the 20th at 8:30, and on the 21st at 8:30. And the moon, the rise times, the difference in time between the 19th and the 20th is only 13 minutes. The difference in time between the 20th and the 21st is 11 minutes. And the difference is between the 21st and the 22nd is 12 minutes. Now you contrast that with 6 months later in March, where the ecliptic angle is extremely steep. The moon rises at on the 27th at 6:40, on the 28th when it's full at 8:10, and on the 29th it rises at 9:40. So the difference between the 27th and the 28th is 90 minutes. And likewise, the difference between the 28th and the 29th is also 90 minutes. So the harvest moon just isn't a sad old song about getting no lovin'. It's very beneficial to in agriculture to give light to help get the crops off. Okay, the constellation I'm going to talk about this month is Cygnus, and it is there it is without the lines. You can see it here. There's the wings. Cygnus is the swan. So there it is with its astronomical lines. You can see the bright star Deneb, which is part of the summer triangle. There's Vega or Vega over there. It's at the tail of the swan. This is the head of the swan with the star Alberio. And then here you have the wings of the swan. And also known as the Northern Cross. But the ancients saw a swan or a long-necked bird up in the sky. At this time, it's almost directly overhead. And when I say at this time, after sunset, 9:30, 10 o'clock, it's almost directly overhead. And there's many features in Cygnus. I can come back next year and talk about other features, but I always only like to pick 2 features in a constellation. So I could probably do this. I'll do this again next year with 2 different features. So one feature is the North American Nebula, which lies, there's Deneb there. North American Nebula is a cloud of ionized gas, roughly 2,500 light years away. There's also another nebula right about here called the Pelican Nebula. I didn't highlight that. I'll talk about that next year. And there is a dark trail of dust in between the 2 nebula, and it's believed that the star that lights both these nebulas is behind that dark cloud of dust. And they estimate it shines with a surface temperature of 40,000 Kelvin, as opposed to our own sun, which shines at 6,000. So it's a fairly hot star. And obviously it's called the North American Nebula because it kind of looks like North America. And it's a fairly large object. It's bigger than the moon. In a dark site, you can see it in binoculars. It's not going to look red. It's going to look kind of gray. The red is just photographs pick up the color of ionized hydrogen where our eyes can't see that frequency of light. The other feature is the double star Alberio, which is right here in the center of the constellation, or in the center of the summer triangle. And Alberio is a beautiful optical double star. Some books say, or some sources say it's a true double star, and the latest seem to indicate it's an optical double. That means they're not gravitationally bound to one another. But it seems the jury's still out on that. They're about 4,000 light years away, or 400 light years away. And there is a large orangey colored star. It doesn't show up very well in this picture, but it has a definite orange hue. And then there's the smaller bluey white star, and it looks really cool in a telescope. It's a favorite object that we show people who come to the observatory when it reopens again out in Coronation Park. It's a favorite object in the fall that we show people, and people really get a kick out of seeing it. Now, before I go on, like all the constellations, it has a bit of a story to it. There's several stories relating to Cygnus, and the one story I found, which I like the most, involved 2 gods who were racing chariots in space. There were 2 friends who were focused on the race that they weren't paying attention. They found themselves getting very close to the sun, and their chariots started to melt, and the friends fell to the earth. One of the friends fell through some trees, which broke his fall, and that friend was Cygnus. And the other landed in a river and was knocked unconscious. Cygnus wanted to save his friend, but he couldn't swim. So he called on Zeus to turn him into a swan so that he could dive to the bottom of the river and save his friend. Zeus was so moved by this sacrifice that after he dived into the river and saved his friend, that he was moved by his bravery, and when the swan died, Zeus placed him in the sky to serve as a reminder of courage and friendship. There was another story I found involving Zeus turning himself into a swan so he could seduce another woman. A lot of the Greek mythology involves Zeus seducing various females. In the Cree culture, the constellation is known as Niska the goose. And in the fall, Niska flies south along the Milky Way to its winter home, where it stays until spring and then returns. So now this is a picture I just took from my backyard. Just set the camera, took a 10-second exposure, and you can see Cygnus there. I drew in the lines. There we go. Alberia denim. And then I took that same picture and I enhanced it because, as the Cree legend says, Niska flies along the Milky Way south, and Cygnus is right inside the Milky Way galaxy. And even in the city with a 10-second exposure, you can, or with binoculars actually, if you looked up, you would see hundreds of stars around Cygnus. So, or you can try it with a photograph. So that's the story of Cygnus. Oh, are there any questions before I go any further? Okay. Other highlights this month. We have zodiacal light in the east before dawn for the first half of the month, when the moon isn't in the sky. And that light is caused by dust along the plane of the solar system that has the sun shining upon it. We have the autumnal equinox on September the 22nd, time of equal day and night. We have my favorite target on the moon, the lunar X, which will be visible on September 13th for a few hours, starting around 4 o'clock in the afternoon, and you can see it in the daytime. You'll need a telescope to see it. And the moon, as I mentioned before, forms a triangle below Saturn and Jupiter on the evenings of the 16th and the 17th. So this is a picture I've took of the lunar X. There it is there. It's caused by sunlight on the tops of 4 craters around the crater Werner, and it forms this X, and it is actually pretty prominent. And there's also another feature further up called the lunar V, and it's further up on the moon. And yeah, it's the same phenomenon, sunlight shining on the tops of craters, forming the V and the X. And as I said, it lasts about 4 hours. And generally we see it in Edmonton about every couple months. It happens every month, but of course the moon is not in our sky for the alternate months when the sunlight is hitting it just right. To say the equinox is the point in its orbit where the sun shines equally on the northern and southern hemisphere, and it's the beginning of our fall in the northern hemisphere and the beginning of spring in the southern hemisphere. And here you can see a little animation with sunlight shining equally on the north and southern hemispheres. And the zodiacal light, it looks like a pyramid of very faint light. You have to be in a very dark spot to see it. And of course, no moon in the sky, which is why I say in the first couple weeks of the month. And it is known as false dawn. And as I said, it's dust in the plane of the solar system, being shined on by the sun. In the fall, you have the same phenomenon, but it's in the evening sky. And just as a side note, this guy, Brian May, who's the lead guitarist for the band Queen, is also has a PhD, and he wrote his thesis studying this phenomenon. Okay. Hey, we're going into the space history section of this presentation. And as I've said before, I picked something that happened in the month in a year that is divisible by 5. So a year that ends with a 1 or a 6. Now, the past few months I've been going back 45, 55, 60 years. Today, I'm not going back that far. I'm only going back 5 years. And we're going back to this space probe. And this space probe is Rosetta, built by the European Space Agency. And its mission was to rendezvous and orbit a comet. After the successful Giotto probe that gave us our first close-up look at a comet, in which case, in this case, Comet Halley in 1986, the European Space Agency decided they were going to try and learn more about comets by actually going to a short period comet, one that orbits around the sun less than 10 years or so, and orbit the comet and then follow it around on its orbit as it makes its closest passage to the sun, and then heads back out. The comet they picked originally was a comet called 46P Wirtanen, and they were going to launch in 2003 to rendezvous with this comet. And they were launching it on an Ariane 5 rocket, which is a European rocket. But the launch immediately before they were going to launch Rosetta failed. And so they wanted to study why that happened, because they didn't want their probe to end up somewhere in the Atlantic Ocean. And so they delayed the launch, and they had to find a new target, in which case, and I'm only going to say this once, they found comet 67P Chernomov-Gerasimenko, which has a 6.4 year orbit. And it is about a small object, which they learned later when they got up close to it, is 6.7 kilometers by 5.6 kilometers, with an area of about 19 cubic kilometers. In the future, I'll just call it 67P. So they launched it on March the 2nd, 2004, and it was going to take 10 years to get to this comet, because you can't just, like a flyby mission, just fly up to a comet and go into orbit. You just don't have the fuel to do it. So you've got to have a really, really slow approach to do this. The mission would last 12 years, and 10 of those years were just getting to the comet. It made a number of gravity assist maneuvers. It made 3 Earth flybys for gravity assists, 1 by Mars. And on its 10-year journey, it flew by 2 asteroids and imaged them. It was fairly large. You can see some people standing in the background. It was 2.8 by 2.1 by a 2-meter cube, but it had these huge solar panels that stretched 32 meters tip to tip. So it was over 100 feet across. So it was, you can see the panels right folded up on the side right here. So once this thing was in space, it was a pretty big hunk of machinery heading out. It was the first solar-powered craft to venture to the orbit of Jupiter. 67P ventures out as far as Jupiter. So this is a animation of its flight path getting to the comet. And why isn't it running? Oh, there it goes. So that was its path, 10 years to get there. Now, there was this one picture that I really liked. This is when it encountered Mars for the gravity assist. And I was really taken with this picture when I first saw it back then. And I remember I sent it to a grade 6 teacher that I was helping with their astronomy course at the time, because it reminded me of looking out the window of a car as you're going past some landmark. So here you are, you're on Rosetta looking out the window with the solar panel in the foreground and Mars in the background. I just thought that was such a really cool picture. Now, when they finally caught up to Rosetta, or pardon me, to 67P, they were kind of expecting the comet to be a potato-shaped object. But as they got closer and closer to it, a different shape sort of emerged. And I'm sure more than one of the team looking at these pictures had a certain song going in their head.
Oh, rubber ducky, you're the one. You make bath time lots of fun. Rubber ducky, I'm awfully fond of you. Bo-bo-bo-dee-o, rubber ducky, joy of joys. When I squeeze you, you make noise. Rubber ducky, you're my very best friend, it's true. Oh, every day when I...
So yes, it looked like a big rubber duck. There's an artist's conception of Rosetta orbiting the comet. It was 2 lobes joined together at a neck, a big one for its body and one for the head. And they were really surprised. It also would cause some problems when, because Rosetta also carried a lander, which I'll get to in a minute, trying to figure out where to put the lander down. As I said, they were expecting a potato-shaped object, which would give them lots of choices. But with this twin lobe thing, they really had to work on trying to find a spot to land their lander. And there's a close-up, and you can see the scalloped terrain of this thing. Not at all what they were expecting. So here are some, oh, I see there's a whole bunch of chats. I should just have a look and see what's going on. Thanks. Okay. What was the name of the double star? Oh, that was Alberio. And oh, I see it was answered. Never mind. Okay, so this is some pictures as the comet got closer to the sun. It started outgassing, and what they found, what Rosetta found, as it took samples of the gas expelled from the comet, that it had a higher level of deuterium in it, in the water vapor. Deuterium is heavy hydrogen. Normal hydrogen is a proton nucleus and one electron. Heavy hydrogen has a proton and a neutron in its nucleus, and then a single electron. So they found it had higher levels of deuterium than water found on Earth. And they also found organic compounds, amino acids like glycine, ethanol, complex carbon molecules. The plasma detectors picked up a low frequency hum caused by the gas and dust interacting with the solar wind. And of course, as I showed you before, the complex topography, the scallops, little cliffs and such, and the double lob shape was a complete surprise to the researchers. There we go. Okay, Rosetta carried a little lander, and it was called Philae, and it was about the size of a small dishwasher. And it was released from Rosetta on November the 12th, 2014. Now, when it, after they scouted out a good place for it to land. When it landed, and it landed at a very, very slow velocity, because the comet isn't very big. It has a very weak gravity field. If you were standing on it, you could walking at a normal pace would easily throw you into orbit, and if you ran, you could run right out of orbit and float into a solar orbit. Very weak gravity. So to account for that, the lander was going to fire harpoons into the comet and anchor it in the weak gravity, and the legs also had some screws to hold it in place, because they thought the comet was going to be soft and fluffy. And when it landed, it was supposed to kind of look like this, sitting on the surface with its solar panels gathering energy, taking readings, had a little drill on it to drill into the surface. But below the surface dust, it was solid. It was solid ice, and as hard as steel. So when the harpoons fired, all it did was cause Philae to bounce a couple times before landing against an outcrop. So I've got a little animation of what that might have looked like. So there you go. I sped it up because the whole thing takes about 5 minutes, this animation, so I sped it up. So there's old Philae flying above the comet and coming to rest. And it came to rest under an outcrop. And its solar batteries were unable to charge, and it ran out in a few days. A few months later, as the comet continued in the orbit, sunlight did fall upon the lander, and it woke up for a time before falling silent for good. Now, this is a picture Philae took from the surface. You can see there's a little bit of soil, rocks, and such. But underneath all the surface, it's just ice, hard ice. So it did carry a little drill, but it was unable to penetrate the ice. But it did detect 16 organic chemicals like methyl isocyanate, acetone, acetamide, hydrogen sulfide, ammonia, and hydrogen cyanide. Some of the research commented that the comet, if you could pick up a piece of it and give it a whiff, would smell like something between rotten eggs and cat urine, which isn't a great smell. Owning a cat myself. Now, Rosetta in orbit, it lowered its orbit as it got near the end of its mission, and it was eventually able to spot Philae, this big picture here, shows it, and here's a blow up, and there's Philae lying on his side in shadow under a rock. Now, all these dates, why am I picking this date? It's because on September 30th, 2016, it was Rosetta ended its mission, and how it ended its mission is it did a crash landing onto the surface of the comet and took and sent readings all the way to the end before landing on the surface. It probably bounced, tumbled, and it wouldn't have landed very hard, but I imagine in its tumbling, it probably clipped its antenna, its high gain antenna, and no more signals were ever received from it once it landed on the surface of the comet. And here's a little video of the descent. Rosetta had several cameras, so you'll see the view flipping back and forth. And again, I've sped this up because this does take quite a while to get down, but here's a video of the landing. And this is the final image sent from Rosetta. Well, the reason they did end the mission is because it was running low of fuel. And if they just let it run out completely, it would eventually smash into the comet anyway. But they wanted to get some science before that happened, and be able to steer the probe so that its antenna was pointed at Earth. So with that is the end of the history presentation. That's the end of this presentation. I always mention Heavens Above because it's a great source of information. It has star maps, has satellite maps. In addition to the spotthestation.nasa.gov, Heavens Above also shows timings for the ISS and several other satellites. Our next What's Up is going to be on Wednesday, October the 6th at 7:30. I'll remind you that the next general meeting of the RASC Edmonton chapter will be on Monday, September the 13th at 7:30. The speaker is going to be talking about the James Webb Space Telescope, which just finished its final testing and will be shipped to the ESA's launching facility in French Guiana, where it will be launched on an Ariane 5 rocket, the same rocket that took Rosetta. And Alistair Ling, who's with us tonight, does his introduction to stargazing every month on the fourth Wednesday of the month. His next one is on September 22nd. All these times are at 7:30. And with that, I'll say thank you. And are there any questions?
Thank you, Jeff. One of the things I really loved about the Rosetta mission is that you could see that it wasn't just, like you said, a potato, but that just uniformly putting out dust. You could see these fantastic jets. And that's one of the things that makes comet orbits sometimes difficult to predict, because those jets are literally mini rockets that are pushing the comet into a different orbit, slightly, but enough to throw off calculations as if compared to it being a bare rock.
Yeah, that's true.
Yeah, that was pretty neat watching that. It just amazes me how they could pick a little object like that and put a spaceship on it.
Yeah, it's amazing what we can do now.
Mhm. Cool. Well, anyway, thank you very much, Jeff.
Yeah, you're welcome. Thank you. All right. If there's nothing else, I don't see anything in the chat. Thanks to everybody who joined us tonight. If you're from Edmonton, I hope this has been of some help or use. If you were from another part of the country, thank you for joining us tonight. And so, if there's nothing else, I will say good night and thank you very much. Oh, thank you, Lucas. That was great. Thank you, Marnie. Thanks. Very nice. So hopefully we'll see some or all of you next month on October the 6th for another What's Up. All right. Thanks very much. Good night.
Night.